Once you are done, send the answers on WhatsApp. Okay, Sarah, so the first one is correct. Second one is also correct. And third one is also correct. Yeah, fourth one is also correct. Very good for doing the minor and major thing. And yeah, fifth is fine. Yeah, that is also fine. Six is fine. Yes, very good. Very good, Sarah. Waiting for others. Please send me whatever you have done. Let us see that. Sarah, that will do today. Okay. And like if you think about, you just need to join both of those things in the second question. The benzene from the chlorobenzene and the methyl from the methyl chloride. Okay, I think we did not do. Okay, Fatima is looking at yours. In the last class, we did only what woods, right? Yeah. Okay. So Fatima, first one is fine. Second one is fine. Third one is fine. Major minor बता दीजिए fourth वाले में. Okay. Show which one is major minor. And fifth one is correct. Sixth one is not right. Seventh one is fine. Sixth one is not right. Ahmed. First is correct. Second is correct. Third is correct.
Sir.
हाँ बताइए.
Sir, I forgot to send the fourth one. That also.
Forgot to send. आपने लिखा ही नहीं है.
So that was an old photo, and then I did the fourth one. And
अच्छा अच्छा ठीक है, नया फोटो ले लीजिए. ओके ओके तो ठीक है. अच्छा ड्राई थ्रो वाला आपने नहीं किया. ओके सामिया लुकिंग एट योर. हाँ 7 and 6 आर फाइन सामिया. अच्छा आपको फिफ्थ याद नहीं है. मेजर माइनर वाला सही है आपका. थर्ड आपको नहीं याद. एंड या दैट्स आल्सो करेक्ट. ओके Razan, waiting for you only now. Everyone has sent the answer. Please send whatever you have done. Yeah, that's right. That's right, Ahmed. Fourth one सही है अब आपका. Radhan, please send the answers quickly. फिर क्लास में पढ़ाना भी है ना, Radhan जल्दी भेज दीजिए. नहीं, आपका ये सही नहीं है. वेट एक सेकंड, सामिया का भी शायद वो सही नहीं था. हाँ सामिया, आपका भी सिक्स्थ सही नहीं है. ठीक है, एक सेकंड. फातिमा का तो नहीं है. सारा सारा आपका भी सिक्स नहीं है. आप लोग ने एक गलती कर दी है सिक्स वाले में. चलिए ठीक है, हम बताते हैं. अगेन इट इज सेम थिंग. आप नंबर ऑफ कार्बन एटम्स तो कम से कम काउंट कर लिया कीजिए. ठीक है, दिस विल बी Cl. ये सही है सबका. दिस विल बी Br. In the presence of peroxide, it will be giving you Br at the corner. Alcoholic OH में you are going to get two products. एक प्रोडक्ट तो आपका ये होगा. This will be minor. Plus you are going to get this product. This will be major. KNO2 में ONO होता है. So in place of Br, we'll write ONO. अब यहाँ पे देखिए, we have two carbon atoms only ना. ये दो कार्बन एटम को बनाइए, चार कार्बन एटम बन जाएंगे. 1 2 3 4, ये होगा आपका ना प्रोडक्ट. ऐसे बनाते हैं आप लोग. This is the Br. This is the carbon where Br was present. This is the carbon where Br was present. दोनों को ज्वाइन करना था. ठीक है, आप लोगों ने 6 कार्बन बना दिया है. That's not right. This was the carbon holding Br. This was the carbon holding Br. यहाँ पे most of you have done is correct. This carbon was holding chlorine. This carbon was holding chlorine. ठीक है गाइस, आप लोग मतलब कि यू डोंट रीडू दीज क्वेश्चंस. असाइनमेंट तो कम लोग करते हैं. सवाल है जो उनको फिर से दोबारा भी कर लिया कीजिए कम से कम. एंड इफ यू आर कॉन्स्टेंटली मेकिंग मिस्टेक, तो फिर वो मिस्टेक हमेशा आपसे होते रहेगी. ठीक है, अभी जैसे हमने करेक्ट कर लिया तो फॉर अ फ्रैक्शन ऑफ सेकंड्स आपको ये समझ में आया. लेकिन फिर से जब हम इस तरह सवाल देंगे, फिर से आप वही सेम गलती कीजिएगा. ठीक है, इसलिए बोलते हैं दोबारा क्वेश्चन को कर लिया कीजिए. जब हम नहीं बता रहे, कम से कम एक बार तो ऐसा हो ना जो आप सही आंसर लेके आ रहे हैं. हर बार हमको सही अगर आंसर देना पड़ रहा है, यानी कि आपको नहीं समझ में आ रहा है. ठीक है, थोड़ा टाइम दिया कीजिए, क्लास के बाद पढ़ा कीजिए. ओके राइट. अगेन अब फिर ये तो कार्बन एटम्स के नंबर काउंट करना चाहिए था आप लोगों को उसमें कम से कम. चलिए. So we did Wood's reaction, right? We did Wood's reaction. Okay. Now in Wood's reaction, write some remarks. Okay, right. This reaction is not applicable. Not applicable for two different haloalkanes.
So this is for Wood's reaction?
Yeah. Remarks is for Wood's reaction. This reaction is not applicable for two different haloalkanes because it gives mixture of alkane which is difficult to separate. Which is difficult to separate. For example, if I do a reaction like this, now CH3Br plus CH3 CH2Br in the presence of Na and dry ether. In the presence of Na and dry ether. Now there will be some ethyl bromide which will not know that there is ethyl bromide also present, right? Some of the methyl bromide, they will react with themselves and they will form CH3, CH3. Some of the ethyl bromide, they will just form CH3, CH2, and then CH2, CH3. Right? Now, some of the methyl and the ethyl bromide, they will react with each other and they're going to form CH3, CH2, CH3. Okay. So now these all product, as you can see, it is what? This is ethane. This is this is ethane, propane, and butane. So the number of carbon atoms is not very different. Okay. So difference in the number of carbon atoms is not very high, and that is why they will have similar boiling points. And if something is having similar boiling point, then we cannot separate them via simple method of distillation. Okay, that is why what is happening. That is why in this case we don't have any reaction in which there are two different haloalkanes. हम लोग एक ही haloalkane करते हैं. For example, I will do for methyl bromide or ethyl bromide to get the double the number of carbon atoms. Second remark that you have to write is Wood's reaction is not given by tertiary haloalkanes. That means if I will have something like this, CH3 carbon, CH3, and halogen atom, plus there will be sodium atoms in the presence of dry ether. The first step that happens is this is going to be broken. The CX bond will get CH3, and CH3 negative, right? And CH3 negative. Now this CH3 negative has to attack one more atom of this, one more molecule of the same substrate. CH3, C, CH3, CH3, X. Now this is going to attack here, and then this is going to move away. But as you can see, this is a very large molecule, right? This very large molecule, it will rather not, it cannot attack on this carbon atom because of steric hindrance. There are many CH3 groups present. So what it will do, it will act as a base rather than a nucleophile. So rather than, because it is big in size, if you remember alkoxide and hydroxide ka difference, then that alkoxide was bigger. That is why it attacked on hydrogen rather than carbon. So here also what is going to happen, it will attack on hydrogen. Hydrogen will give the electrons into this, forming a pi bond, and it will form an alkene. So the product that you are going to get is this carbon atom, it will become CH3, double bond CH2. One of the hydrogen has been taken away by this tertiary carbon ion. And here we are having CH3. This X has been, the CX bond has been broken, and X leaves us X negative. Okay, so what you are getting, you are getting alkene. Remember this reaction, Wood's reaction is not given by tertiary haloalkane. And the reason is why? Because of steric hindrance, it does not attack on the carbon atom making an alkene, rather it attacks on the hydrogen atom forming alkenes. Right? Since tertiary haloalkenes undergo elimination, they form alkene as major product. Right, next, Fittig reaction. This is the second reaction with sodium, Fittig reaction. Please write. When two same haloarenes react with sodium in the presence of dry ether. It forms biphenyl. And the reaction is called Pvt reaction. Okay, so the general scheme of reaction is going to be a benzene ring with halogen atom plus 2Na. This will have two same molecules in the presence of same thing, dry ether. What you are going to get? Okay, this is known as biphenyl or diphenyl. दोनों ही बोलते हैं इसको biphenyl or diphenyl. I'm writing some specific examples. Suppose you have Br plus 2 sodium, presence of dry ether. You're going to get biphenyl, like this, simple. You can have something like this also. Suppose we have Cl and we have CS3 here, right? Plus 2Na. तो यहाँ पे देखिए आप कैसे कीजिएगा. Here we have CS3. This is the carbon containing Cl. Benzene ring. This is the carbon containing Cl. This is your CS3. Just join these two. The carbon containing the halogen atom. So the question, how will you convert? एक तो आपका जो वुड्स रिएक्शन से है, there is one question. 1 chlorobutane. 2 octane. 2 normal octane. It's quite simple. You have chlorobutane 1, 2, 3, 4, and then the chlorine atom. So this is 4 carbon atoms. Okay. 2 N-octane. You just need sodium in the presence of dry ether. You will get 1, 2, 3, 4, 5, 6, 7. This will be 8. No? 2, 3, 4. Yeah, this is 8 carbon atoms. Second question is more interesting. Please see. How are you going to convert benzene to बाइफेनाइल? एक जगह इस तरह से सवाल है. एंड एनसीईआरटी में भी आपके पास एक और सवाल है जिसमें उन्होंने पूछा है हाउ विल यू कन्वर्ट बेंजीन टू डाइफेनाइल. Okay, so for both of these we are going to have the same reaction. First of all, we'll have to convert benzene to chlorobenzene. So we have benzene plus Cl2 in the presence of AlCl3. This is the reaction that we have already done. What we are going to get? We are going to get here a chlorine atom in any one of the carbon atoms. Chlorine. Now, when this chlorine is going to be reacted with sodium in the presence of dry ether, Pvt reaction will take place. We are going to get biphenyl. प्रैक्टिस कीजिए, ठीक है. these are hand skill. पढ़िए मत ऑर्गेनिक केमिस्ट्री. आपको पेन और कॉपी लेके रफ नोटबुक लेके उसमें बैठना पड़ेगा, रिएक्शन लिखना पड़ेगा. देन ओनली यू विल अंडरस्टैंड द पैटर्न्स. ओके. Until unless you are writing these things down once or twice or even thrice, तभी आपको आएगा. आप 10 बार रिकॉर्डिंग भी सुन लीजिएगा लेक्चर का, तब भी वो आपको कॉन्फिडेंस नहीं आएगा जब तक आप खुद से हाथ मूव ना कराएं, स्ट्रक्चर्स को ना बनाएं, रिएजेंट्स का नाम ना लिखें। Done, guys? Yes, no, please tell me.
Yes, sir.
Right, next. Woods-Fittig reaction.
Sir,
And Woods-Fittig reaction,
could you
we
just
take
go up for 1 second?
you want to scroll up.
Sir, done. Sir. Done.
Woods-Fittig reaction. Done. Right. When one molecule of haloalkane and one molecule of haloarene reacts with sodium in the presence of dry ether to form alkyl benzene, the reaction is called Woods-Fittig reaction. So the reaction happens something like this. We have benzene ring with a halogen atom attached. Thus we have some haloalkane, RX, in the presence of sodium and dry ether. What is going to happen? This alkyl group will attach on the benzene ring. Okay. So write some specific examples. Let's suppose we have chlorobenzene and CH3Cl. The presence of sodium and dry ether. The benzene ring will get attached with CH3. Let's suppose we have something like this. Plus chlorine here. Okay, so please remember that this carbon atom is going to get attached on the benzene ring. Okay, the halogen containing. So we have a bond like this. देखिए, now you have to explore, like you can write the reaction ऐसे करके आपके पास मान लीजिए Br है, plus if you have something like this Br, okay, तो इसमें आपकी मर्जी है, आप क्या लिख सकते हैं पता है? You can also write it like this, Br की जगह में benzene ring, right? You either draw it like this or you draw it like this. जहां पे भी आप ज्यादा कंफर्टेबल हैं, you can draw it. It is just that you have to see, you have to map the carbon atoms. Okay, so 1, 2, 3, 4, right? So the second carbon should be attached on 1, 2, 3, 4, 5, and 6. So the second carbon should be attached on the first carbon atom. तो आपने क्या लिखा है? 1, 2, 3, 4 लिख दिया आपने, सेकंड कार्बन को फर्स्ट कार्बन में अटैच कर दीजिए. That's it. यहाँ पे आपने यहाँ पे ऐसे किया 1, 2, 3, 4, 5, 6. You labeled it, then you are attaching here. So this is 1, 2, 3, 4. ये फर्स्ट कार्बन एंड दिस फर्स्ट कार्बन शुड बी सेम, दोनों सेम है. The second carbon was having, yeah, the second carbon is now having benzene. That is also fine. Then we have the third carbon atom, then the fourth carbon atom. That is also fine. Okay. So try these things of mapping the carbon atoms after you are done. After you have made the product, then you should be able to see. देखिए यहाँ जैसे आपको यहाँ पे दिखा होगा. Let me label this as blue. Okay, and so you can see that ये portion जो है ना आपका, this is from the blue. ठीक है. So इस तरह से कार्बन एटम्स की मैपिंग कम से कम आप लोग को आनी चाहिए, तब मिस्टेक नहीं होगा. So whenever you are redoing these things ना, try एक बार चेक करने के लिए इस तरह से मैप कर लिया कीजिए कि कहीं आपके कार्बन एटम्स बढ़ या घट तो नहीं रहे. You should have an account of the carbon atoms. Done everyone? Yes or no? Please tell me.
No, sir.
No? चलिए लिखिए, आराम से लिखिए.
Ten, sir.
Sorry. Let's move on. And now we are going to talk about the chemical properties of haloarene. Okay, now we are going to talk about the chemical properties of haloarene. Now, something that you have to do now, once this is complete, the haloalkane part is complete, right? So you should have at least 2 pages now. One page should give you all the method of preparation of haloalkenes. All the method of preparation of haloarene. And since we have done the chemical properties of haloalkene, we should have all the chemical reactions, all the reactions of haloalkane. Okay, so all of these things, these are going to be very helpful. And उसके बाद अभी जब हम लोग पढ़ लेंगे ये सारा, like once we are done with the electrophilic substitution of haloarene, once we read the reactions of haloarene, we will also write all the reactions of haloarene. Now, once you're done with this 4 pages, once you have all of these 4, then all of these things, they are going to help you in conversions. जिनके स्कूल में हो गया है, I think you will face like the most difficult thing that people student face is conversions in organic chemistry. Okay, so until unless you have this, okay, so you should have this reaction maps in one pages. Okay, in one pages. And the second thing that you need for conversion, and you can never do conversion without it, is IUPAC nomenclature. And rather than IUPAC nomenclature, that means if you have name, you should be able to draw the structure. Now these are the 2 things that you need. Now, so starting में क्या करेंगे? Once we do conversions, I will do all the conversions, okay, of haloalkane and haloarene. We will take one separate class for only conversions. Don't worry about that. But when we are doing conversions, I need these 4 things with you, and I need this in your head. Okay, this should be in sheets, and IUPAC naming should be in your head. आपको आना चाहिए name से structure बनाने के लिए. Exam में क्या होगा? ये सारी चीजें आपके दिमाग में ही होनी चाहिए. Okay, everything should be in your head. Then only you will understand the conversions. But again, conversions में there are some patterns. Okay, and मेरे start करने से पहले आप लोग conversions नहीं कीजिएगा NCERT के. Like they have not जो उनका level है ना, convergence का, like for example the first question it is very difficult, second question फिर आसान है, third question, so that difficulty level जो है ना level up सही से नहीं हुआ है. I have arranged all the questions in such a manner that they follow a pattern. Then you will understand that some certain reactions are very important and very important only for convergence. Okay, so उन reactions पे ज़्यादा focus हम लोग करेंगे फिर, right? So please don't start convergence before my class. Okay, class से पहले आप convergence मत start कीजिएगा. Now we are going to write about, please write electrophilic substitution of halogenes. Electrophilic substitution of haloarenes. Okay. Now, we'll first of all write that haloarenes, if electrophilic substitution is happening, then haloarenes are going to be what? Electron rich. Okay, and there should be some specific sites from which it can attack. So please write haloarenes are ortho-para-directing. Due to plus M effect of halogens via resonance. What does this mean? If you look at any haloarene, there is X, this has 3 lone pair electrons, and A double bond B, single bond C, and C is having lone pair electrons. Now this is a condition of resonance which has been fulfilled. So there will be resonance like this from electron source to electron sink. Now what is going to happen? The lone pair electrons are getting converted to pi bond, and the pi bond is getting converted to negative charge. So you'll get double bond X. Now since X has given electron, it will get a positive charge, and this pi bond has traveled to this carbon atom, forming a negative charge here. Now these bonds are intact as it is, nothing has happened here. Now again you can see A double bond B, single bond C, and C has a negative charge. Again a resonance can take place. Negative charge will form pi bond will form negative charge.
So when does resonance take place?
When does resonance take place? There are certain conditions. You don't have 11th class lectures, Fatima?
No, sir.
नहीं है आपके पास, आपको हमने नहीं दिया है. I think हमने दिया है, नहीं दिया है. दिया है हमने फातिमा, ठीक है.
Yes,
इसमें आपके पास,
Yeah, it's there, sir.
ठीक है. There will be a topic of resonance. ठीक है, तो वहां पे आप देखिए there are several conditions of resonance. Generally आपके पास क्या होना चाहिए हम बता देंगे आप. There should be some atom A which has a double bond with B. This B should have a double bond with C, and this C should have either a positive charge, negative charge, a lone pair electron, or a single radical, or it should have a double bond. ठीक है. So majority of the cases are covered here. इसको कहीं साइड पे आप लिख लीजिए, ठीक है. या तो अब ये अलग अलग केस है, ठीक है ना. ऐसे कोई एटम नहीं रहता, पता नहीं आप क्या समझिएगा नहीं समझिएगा, समझ ही नहीं आता. सी A double bond B single positive charge, ठीक है. or you should have negative charge. यानी A double bond B single bond C negative charge. अगर ये भी हुआ, then it is going to show resonance. Similarly, A double bond B single bond C lone pair electron. This is going to show resonance. A double bond B single bond C a free radical. This is going to show resonance. ठीक है?
Sir, I understood.
हाँ ठीक है. Okay, thank you very much. समझ गए आप, तो समझदार हैं आप. Okay. Please, like resonance जिन लोगों ने नहीं देखा, please देख लीजिए resonance. Okay. Right, next. This double bond X has not changed, so this will be again same positive here. This negative charge will convert to pi bond. This pi bond will convert to negative charge, and like this. Now again you can see there is A double bond B, single bond C, and C has a negative charge. So again there will be a resonance like this. And you are going to get this double bond X positive has not changed. Nothing is happening here. Nothing is happening here. We are getting a new pi bond here, and we are getting a negative charge here. Again, at last you can see A double bond B, single bond C, and C has a negative charge. So there will be again resonance, pi bond, and pi bond will go there to X, and X will be neutralized. X, this has all the lone pairs now. The double bond is here, double bond is here, and double bond is here. Now from here we can say that none of these structures are real. Okay, so the mixture of all of these structures are real. So कोई एक structure उसमें से real नहीं है. Everything is real and everything is unreal here. Now if you get all of these, you will get the resonance hybrid. So resonance hybrid will be having, see this X here, it will have a partial double bond character because sometimes it is single, sometimes it is double. Right? There are 1, 2, 3, 4, 5 structures. In 5 of the structures, 3 times it is having double bond and 2 times it is having single bond. That means partial double bond character. Now, if you look at any of the bonds, it is sometimes double, sometimes single. That means all of the bond on the benzene ring are what? These are having partial double bond character. Now, let us look at the carbon atoms. If you look at this first carbon atom, right? This first carbon atom is not having any charge in any one of them. All the 5 resonance structure, they are not having any charge on the first carbon atom. Let us look at the second carbon atom. So it is neutral. Here the second carbon atom is negative. Here the second carbon atom is neutral. Here it is neutral, and here it is neutral. So I can say that there is delta negative charge in this second carbon atom, delta negative. Let's look at the third carbon atom, neutral, 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 and neutral. Okay, so this carbon atom will not have any charge. Let us look at the fourth one. The fourth one is neutral here. It is neutral here, but it is having negative charge. It is neutral here and neutral here. So I can say that it is also going to have a delta negative charge. Then let us look at the fifth one. Fifth one is also, you can see, it's neutral everywhere. 5 is neutral, 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 and neutral, no charge. Sixth carbon atom here, it is having neutral, 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 and then there is a negative charge, then again neutral. So I will say that these are the different positions in which we are having delta negative charges. As you can see, that all of these places, these positions, this is ortho, this is para, and this is ortho, right? That is why the attack can take place either from the ortho direction. It can not either. It will take place from the ortho and the para direction. Okay, so these are the 2 positions from which you can have attack towards the electrophile. Electrophile means electron-loving species. Who will give the electron to electron-loving species? The benzene is going to give electron to the electron-loving species. Okay. So that is why we can say that haloarenes will attack. अब देखिए जहां से अटैक होता है ना वहीं से बॉन्ड बनता है, ये याद रखिएगा प्लीज. ओके, सो इफ यू आर अटैकिंग फ्रॉम समवेयर, दैट मींस दैट particular atom is going to make a bond. Haloarenes will attack from ortho and para positions and form ortho and para products. Done everyone? Yes or no, please tell me. All of you done?
Done, sir.
Done?
Done, sir.
Is anyone writing?
No, sir.
Okay. Chalo. Now let's write a question. Haloalkanes show SN, nucleophilic substitution, but haloarenes show electrophilic substitution, SE, reactions. Why? ठीक है? ठीक है. Please see यहाँ पे ना बहुत like you will get questions which will seem similar. Okay, so these are different questions. For example, haloalkanes show SN, but haloarenes show SE. In this case, you have to give me answer, and the question is explain this. Why haloalkanes show SN, and then also explain me why haloarenes shows SE. एक सवाल आएगा where they will be asking you why haloarenes do not show SN. Then in that case, you just have to answer why they do not show SN. लेकिन यहाँ पे please see specific questions will have specific answers. Okay. In this case, what we are going to answer, we are going to answer why haloalkanes show SN and haloarenes they show SE. So please write first of all. This will be answer, not solution. First of all, we'll explain why haloalkanes show SN. Please write. In haloalkane, the alkyl group is attached to more electronegative element, X. X मतलब क्या आपका halogen. Due to which partial positive charge is created at carbon, carbon atom of CX bond. Okay, if positive charge is there, then what is going to attack? Hence, nucleophile. Attacks and haloalkane shows SN. Right, next. But in haloarenes, the benzene ring is electron rich. And hence it attacks the electrophile and shows SE. प्लीज ध्यान दीजिएगा, हमने ये नहीं बोला कि SN क्यों नहीं दिखाता, दे आर नॉट आस्किंग दैट. Okay, what they are asking, why it is showing SE, tell me about that. Okay, so we have to answer why it is showing SE. जब वो पूछेंगे कि SN क्यों नहीं दिखाता, then we will answer why they don't show SN. But right now they are asking why it shows SE. So we are writing the answer for why it shows SE. Electrophilic substitution. अब यहाँ बहुत ही तरीके से क्या किया, we'll show it diagrammatically also. We have Rx. Here X is getting delta negative charge because of higher electronegativity. This is getting delta positive charge. And then we have a nucleophile, which will obviously have at least a lone pair electron. This is going to attack on this R. But if we have a benzene ring with a halogen atom, right, then this benzene ring is going to attack on the electrophile. Electrophile is something which is positively charged and it loves electron. Is everyone done? Yes or no? Please tell me. Is everyone done? No.
Done, sir.
Done. Okay, right next. Haloarenes show following electrophilic substitution reaction. Okay, please write number 1, halogenation. Number 2, nitration. Number 3, sulfonation. Number 4, filter craft. Alkylation. 5th, filter crafts acylation. So, right, number 1, halogenation.
Can I leave the
Achha, so you have to leave, no? Yeah, sure.
time, sir?
Okay,
Thank you.
Thank you. Okay. Halogenation. So let's look at the reaction and let's look at the product. Uske baad, we will also look at the mechanism. So for halogenation of, let us suppose we have X, the reagents that we need is Cl2 in the presence of AlCl3. Okay, AlCl3. In this case, what is going to happen? The chlorine atom is getting attached on the ortho and para positions. Okay, so एक product बनेगा आपको ortho से. Everything will be as it is. Cl plus you will get one product in the para position. Okay, so this is one. Now this is a general scheme of reactions. कुछ specific examples की अगर हम बात करें, This Br will be as it is. You will get chlorine here. Plus, you will get a chlorine in the para position. Okay, always this is going to be your major product, the para one, because as you can see, chlorine, this benzene can easily attack from this para position because you have to put steric hindrance name. But X that is present here, which is near to ortho, it is going to show some steric hindrance. This will be minor. Right, some more. देखिए Cl, this is also ortho, ठीक है? Cl and this will be Cl, para. 2 carbon का difference, para, 0 carbon का difference, it is ortho. Let's suppose you have something else to add. Let's suppose you have to add Br. Then you'll react this with Br2 and you're going to take the Lewis acid FeBr3. The product that you will be getting is Br and Br plus Br and Br. Let us see, look at the mechanism, okay? So there will be one thing very common in all the mechanism. The first step is always going to be formation of electrophile, okay? Formation of electrophile E positive. So the reagents that we have is Cl2, that means you have Cl which is bonded with another Cl. The Cl, they have all lone pair electrons, 3 lone pair to be exact. And then we have AlCl3. If you look at the structure of AlCl3, it is something like this. There is chlorine here, there is chlorine here, and there is chlorine here. If you look at the aluminium, this thing has 3 bonds. 3 bonds means 6 electrons. That means obviously it is not having the complete octet. So there will be a p orbital like this, which will be vacant. There will be p orbital which is going to be vacant. Now this p orbital will be attacked by the electron-rich chlorine negatives. Okay. So what is going to happen? The chlorine with its electron, it is going to attack onto this empty p orbital, leading to formation of, now this chlorine, it has lost a bond and both of these electrons are going here. So you'll have Cl positive now, plus AlCl4, and now this Cl is aluminium, which was neutral, some extra electron, that is why it will be negatively charged. Okay, now we have the Cl positive. Now this Cl positive is going to be your electrophile. What is going to happen next? Please write next. Attack on E positive. Both of these things are going to happen in all of the electrophilic substitution reactions that we are going to see. So we have benzene here. So let's add Cl. Okay, this Cl ये कहाँ से आ रहा है? एक सेकंड रुकिए, आपको पागल लगेगा फिर. यहाँ पे X डाल रहे हैं, ठीक है? Haloarene. In general, haloarene you are having, and you have the electrophile Cl positive. Now, if I go and attack from the ortho position like this, then we are going to form this X will be as it is. This pi bond will break. and you will see that this particular carbon atom, each of these carbon atom except this one, all of them are having hydrogens, right? तभी आपका 4 bond complete होगा. So it has a hydrogen atom like this, and now it has added a chlorine atom like this. Has added a chlorine atom like this. Okay. Now, if you see here, this particular carbon atom, it initially had 1, 2, 3, and 4 bonds. Now it has only 3 bonds. That is why this will get a positive charge. And again, as you can see, यहाँ पे hydrogen है, यहाँ पे positive charge है. दोनों के lobes interact करेंगे. This hydrogen will give the electron towards the positive charge to get aromaticity, because resonance is important. Hydrogen ने उसको electron दिया. You form a double bond like this once again. The X is here like this. The chlorine is here, and you have also got the resonance back. So resonance is there for the stabilization, and that is why the hydrogen, it easily gives the electron towards that positive charge to regain the resonance or regain the aromaticity. Similar thing can happen if you have a attack from the para position also. So we have all of these bonds intact as it is. Here we have the X halogen atom, we have chlorine positive, and then you are having attack from this para position. The chlorine will get attached on the para position. This X is as it is. This bond is as it is. This bond is as it is. We're getting a chlorine atom here like this. There is a hydrogen attached, and this is going to get a positive charge. Now this hydrogen will again give the electrons to regain the aromaticity and resonance, leading to formation of X, this pi bond here, this pi bond here, this pi bond here, and the chlorine in the para position. Okay, so this attack is going to be same in all of the cases. The thing that is going to change always is the formation of electrophile. Okay, how the electrophile is being formed, that is going to be different in all of the next reaction. But attack on the electrophile, it is going to be the same. The benzene is going to attack from the ortho and para position. Then the electrophile will get attached on the ortho and para position. And then the hydrogen is going to give the electrons on the benzene ring to regain the aromaticity and the resonance for stability. Same things. Write this down. You have to always understand the driving force, why something is happening. For example, why the sigma bond is breaking. The sigma bond is breaking because the CH bond is breaking, because we have to get the resonance back again, because resonance is there for stability. Okay, resonance brings stability. That is why we are sacrificing what? We are sacrificing a sigma bond in order to regain the aromaticity and the resonance. Done, everyone, guys? लिख लिया आप लोगों ने? नहीं लिखा?
Done, sir.
Done.
Done, sir.
Right, next, second one, nitration. In nitration, let us start with some halogen atom like this. X. Plus we need concentrated HNO3. In the presence of concentrated H2SO4. Nitro group is going to get attached. X, देखिए लास्ट टाइम हमने क्या अटैच किया था? क्लोरीन. तो वहां पे Cl पॉजिटिव वाज द इलेक्ट्रोफाइल. हियर वी आर अटैचिंग NO2. तो यहाँ पे आप लोग खुद से इमेजिन कीजिएगा पहले, ठीक है? दिमाग में लेके आइए व्हाट शुड बी द इलेक्ट्रोफाइल. If we attached chlorine, it was Cl positive. Now we are attaching NO2. So this will be again major. तो हमारे पास इलेक्ट्रोफाइल क्या होगा? So we are going to look at the mechanism now. एक दो एग्जांपल्स लिख लीजिए आप लोग. ठीक है, इन दोनों के प्रोडक्ट्स बना लीजिएगा ना आप लोग. Yes or no, tell me. I think you guys can make. Now let's look at the mechanism. The first step is going to be the formation of electrophile. So here the electrophile is going to be formation of NO2 positive, और positive charge होगा नाइट्रोजन पे होगा because nitrogen is getting attached, right? यानी कि बेंजीन रिंग कहाँ अटैक कर रहा होगा? बेंजीन रिंग would have been attacking on the nitrogen atom. That is why NO2 positive and the positive charge will be on NO2. Sorry, the positive charge will be on the nitrogen of NO2. How is this getting formed? Now, if you look at the structure of HNO3, its structure of HNO3 is something like this. We have nitrogen, which has OH bond. There is a double bond with oxygen and a single bond with oxygen like this. Okay, and this single bond is rather dative and coordinate bond, not exactly completely covalent, just like this. Here we have lone pair like this. Here we have lone pair like this. Okay. Then from H2SO4, we are going to get H plus, right? We're going to get H plus. Now this H plus is going to be attacked by the lone pair of electrons of oxygen atom, leading to formation of nitrogen with double bond oxygen, dative bond oxygen, coordinate covalent bond oxygen, and then we are going to have oxygen, hydrogen, another hydrogen. Since oxygen is going to give electrons here, it is going to get a positive charge. Now, whenever you see this type of entity, where you are having H2O with oxygen a positive charge, then obviously this oxygen is going to be so electronegative that it's going to completely take away this electrons. When it completely take away this electrons, we will get nitrogen with its two oxygens and a positive charge. Nitrogen a positive charge. Why? Because oxygen is taking its electron. And we are going to get, now since oxygen is taking electrons, the electrons are negatively charged. It will get attached to the positive charge. It will get neutralized. I will have a neutral H2O molecule. We'll have a neutral H2O molecule. Okay. Now please remember this concentrated H2SO4 is going to give you H plus and SO4 negative. Okay. HSO4 negative. So ये H plus यहाँ से आ रहा from acid. Okay. Please remember this. बाद में बोलिएगा सर कहाँ से आ रहा सर? From H2SO4. लिख लीजिए इसको. Now once we have got the electrophile, we are going to do the second step, that is attack on NO2 positive. So it's as simple as that. You are having benzene ring. Now we are taking some halogen atom also, and we have NO2 positive. It's going to attack here, leading to formation of carbon and NO2 bond in the ortho position, and the cleavage of the pi bond. The pi bond is breaking. We are forming this hydrogen is as it is, carbon NO2 bond, and this carbon is going to get a positive charge. This hydrogen is going to give the electrons to regain the aromaticity and resonance. Now this is the pi and X and NO2. ठीक है? Para position में भी same reaction होगा. We'll have the same reaction in para position also. Done, everyone? Gee, done, guys.
Done, sir.
Done. Okay. So nitration is done. What's next? sulfonation. Now, in sulfonation, what is going to happen? You're again going to have the benzene ring attached to some halogen atom. And the reagent that you're going to use is only concentrated H2SO4. Only what we are going to use? We're going to use concentrated H2SO4. Now, after this, please write. The electrophile that we are going to have here is going to be SO3H, and the positive charge will be on SO3 sulfur atom. X SO3H plus X SO3H. This is again the major. The same things, mechanism. Okay, write some reactions. Okay, you write the reactions products for these, both ortho and para products. So, mechanism. The important thing that we have to learn is formation of SO3H with a positive charge here. Okay, now this is very similar to what happened with nitric acid. Now, first of all, let us write the structure of sulfuric acid. Sulfuric acid has a structure in which there is sulfur atom, which has a double bond with oxygen, another double bond with oxygen, and the rest of these are OH bonds. Don't pair like this, and I'm just showing this OH bond like this. Okay. Now, there will be obviously H plus ions, right? There will be obviously H plus ions. Now, these H plus ions will be attacked by itself. The SO3, H2SO4 is going to attack the H plus of the H plus that is there in the solution via its what lone pair of oxygen atoms. Again, same thing is going to happen. You will have HO with its lone pair, single bond sulfur with a double oxygen with a double bond oxygen. Then you will have oxygen, hydrogen. It has got a new hydrogen atom and a positive charge. You have got again the same fragment. You have oxygen attaching to hydrogen, and there is a positive charge. So it will be so electronegative that it's going to break away. Since it has taken electrons from the sulfur atom is going to get a positive charge. And the water will be neutral, H2O. So this is what this is SO3H with a positive charge on sulfur atom. Now the second step is attack on the electrophile. So let us show this time from the para position. We have the halogen atom X, and there is the electrophile SO3 and positive charge on the sulfur atom. The para carbon attacks on the sulfur atom, and what happens is this SO3H, it gets attached on the para position. This pi bond is intact, nothing is happening here. This pi bond is intact, nothing is happening here. This is having SO3H. Now this carbon atom, it initially had a pi bond. It does not have a pi bond, that is why it's positive charge. There will be a hydrogen to sacrifice its electron for the regaining of aromaticity and resonance. Double bond, double bond, double bond. There will be a X here and SO3H in the para position. Similar attack will happen in it will also occur in the ortho position. Done, guys? Yes or no? Please tell me. All of you done? Not done. जल्दी लिखिए. नहीं हुआ अभी तक, guys. नहीं हुआ.
Done, sir.
हो गया? Done. Done or not done? Not done.
Done, sir.
Done. Oh, चलिए. ठीक है. तो आज के लिए इतना ही, guys. Now the rest two, Friedel-Crafts alkylation and acylation. These two are we are going to look in the next class. Okay. चलिए. अच्छा, next class जो ना थोड़ा लंबा हो सकता है. Okay. I can take like half an hour more.